Hey there, Seahawks, it's Miss Adams, and in this video, we're going to look at basic probability rules. All right, so a probability model is a description of some chance process that consists of two parts, a list of all possible outcomes and the probability for each outcome. The sample space is the list of all possible outcomes. An event is any collection of outcomes from some chance process. So when there's like two things that are happening, those things combine to make an event. The probability of equally likely outcomes. The probability of A is the number of outcomes in event A divided by the total number of outcomes in the sample space. This is only if all of the events are equally likely. The complement rule, the probability of A complement, that little like exponent C stands for complement, is 1 minus the probability of A, where AC is the complement of A. That is, the event that A does not happen. Mutually exclusive. If they have no outcomes in common and so can never occur together, then those events are mutually exclusive. And if they're mutually exclusive, the probability of A and B is equal to 0 because you can't have A and B at the same time. Addition rule for mutually exclusive events. So if I want to find the probability of A or B and the events are mutually exclusive, meaning they can't occur at the same time, then I can just add the probability of A plus the probability of B, only if they're mutually exclusive. All right, so probability models, equally likely outcomes. Suppose you spin a spinner with 3 equal sections, red, blue, and yellow, 2 times. Give a probability model for a chance process. So my sample space, I'm going to list out all of the possibilities. I could get red, then red. I could get red, then blue. I could get red, then yellow. I could get blue, then red. I could get blue, then blue. I can get blue, then yellow. I can get yellow, then red. I can get yellow, then blue. And I can get yellow, then yellow. Okay? So all of these outcomes are equally likely, and the probability is 1 out of 9. So the probability of selecting one of those outcomes is 1/9. All right, define event A as spinning blue at least once. Find the probability of A. So I have 5 outcomes that have at least one blue in them. All right, so I have red and blue, blue and red, blue and blue, blue and yellow, yellow and blue. All right, so the probability of A would be 5 out of 9, which is 0.555 repeating. All right, complement rule. Mrs. Chevette keeps a mystery box in her classroom. If students meet expectations for behavior, they are allowed to draw a slip of paper without looking. The slips are all equally sized, well mixed, and have a name of a prize written on them. Here is the probability model for the prizes that a student can win. So again, I have this probability model here. It has all of the possible outcomes and their probabilities. So one of the outcomes is winning a pencil. One of the outcomes is a piece of candy. All right, so explain why this would be a valid probability model. All right, in order to be a valid probability model, each probability has to be a value between 0 and 1, which they are, and all of the probabilities have to add up to 1. So 0.4 plus 0.25 plus 0.15 plus 0.15 plus 0.05 does equal 1. So this is a valid probability model. Find the probability that a student won't win extra recess time. Okay, well, the probability that they do win extra recess time is 0.05. The probability they don't win extra recess time is the complement, so it's 1 minus the probability that they do win extra recess time. So it's 1 minus 0.05, which is 0.95. So there's a 95% chance that a student won't win extra recess. All right, the addition rule for mutually exclusive events. According to a recent U.S. Census Bureau data, the number of people in U.S. households have the following probability models. Suppose that a household of 5 or more people is considered a large household. Randomly select a U.S. household. Find the probability that the number of people in a household is 4 or fewer. So if it's 4 or fewer, it could be 1 or 2 or 3 or 4. So I'm going to take all of those probabilities. The probability of 1 is 0.28, probability of 2 is 0.34, probability of 3 is 0.16, probability of 4 is 0.13, and I'm going to add them all up together. So it's 0.91. Find the probability that the chosen household is a large household. So in order to be a large household, it is 5 or more. I could add 5 or more, or I can subtract what I just found, which was the smaller household. So it's 1 minus the probability that it's less than or equal to 4. Since I already have that, it's 1 minus 0.91, which is 0.09. I could have also done 0.06 plus 0.02 plus 0.01. All right, go Seahawks.